So in this section, we're now going to dig a lot deeper into the EIGRP topology table, and we're going to look at defining these terms that we see here called feasible distance and reported distance, and why they're important to EIGRP, how it comes up with these numbers, and how we can see these numbers. So as we know, when an EIGRP router receives an incoming update, whether it be an internal update or an external update, doesn't matter, they all go into the same place, the EIGRP topology table. And the first thing the router has to do is to decide, number one, if this incoming route could potentially be a routing loop. Maybe it's a route I already know about, I already advertised to my neighbors, and it's potentially coming right back around to me again. That's the first thing I have to decide. Second thing I have to decide is if it's not a loop, or if this route is the first time I've ever heard about this prefix. Now I have to put in my topology table and make sure that's suitable for potentially going into my routing table as well. So these types of decisions all are based on two different values, feasible distance and reported distance. So this slide here has a lot of verbiage on it. So let me go ahead and whiteboard it for you instead. So I've got two routers in this case, and they're directly connected, and there's some link over here. We'll just call this guy on the left router A. Let's call this guy on the right router B, and we'll call this over here network X. And I've instructed router A. Doesn't really matter if it's via the redistribute command or the network command. I've instructed him to advertise network X to router B. Okay, well, we've seen enough sniffer traces at this point that I think it's pretty clear to you that when an EIGRP update goes out, whether it's an internal update or an external update, doesn't matter, inside that update are what we call the vector metrics of bandwidth, delay, reliability, and load, as well as some other things like hop count and MTU that aren't even really used for anything. They're certainly not used as far as coming up with the EIGRP distance is concerned. So let's just put that in here. Let's just put the critical pieces, bandwidth, delay, reliability, and load. So that's all in there. So when router B receives this update, first thing he's going to do is he's going to take all this stuff, run it through the EIGRP distance formula, and come up with some distance number. And he's going to say, this distance I came up with, so let's just say right here, maybe this equals distance 1,000. So from router B's perspective, he's going to say, in his EIGRP topology table, he's going to say it's via router A, and he's going to say reported distance equals 1,000. So he's going to say, as far as my neighbor's concerned, from router A's perspective, it costs him 1,000 to get to this network. He didn't actually tell me 1,000, but he told me all the things that he uses in his formula. So when I just redid his formula just like he did it, I came up with the same distance that he had. So now I know it costs him 1,000. So that's what we call reported distance. Sometimes you might also see it called advertised distance. Exactly the same thing. It's what your neighbor advertised to you. Key thing to take away from here is that this number is not actually in the update. The individual pieces that went into the formula are in the update. Now router B says, okay, that's great for him. But for me to come up with my actual real total distance to get to that network, I have to factor this link into consideration. So he says, okay, so how am I going to do that? Well, he says, well, I'm going to take the sum of the delays. In other words, I'm going to take the delay he told me as well as the delay I have on my own interface, add those two together, And then in the EIGRP formula, anywhere it says delay, I'll put in that cumulative total. Then I'm going to take the slowest bandwidth, or you might say the lowest bandwidth. So this guy might say, okay, well, my bandwidth to get to that was 100,000. I say, but my bandwidth to get to you is only 25,000. So when I'm coming up with my EIGRP formula, I'm going to toss out your number of 100,000 and I'm going to replace it with 25,000, the weakest link in the chain, the slowest bandwidth along this path. And now that I've got those numbers, I can figure out the total distance, except in EIGRP terminology, we don't call it the total distance, we call it the feasible distance. And the feasible distance in this case might be 1750. So when I factor in my own interface going to you to get to that network, feasible distance is 1750. So nothing new here. This is all CCNA level stuff that we're talking about, but you definitely want to remember what the difference is between reported distance and feasible distance. Now, one other thing, let's take a look and see where you would actually see this. So if I go into my router here, let's see, we're in router 18 in this case. Let's go to router 19, show IP route EIGRP. Okay, good, so he's got an EIGRP entry. If I do show IP EIGRP topology, so let's take a look at this last one right here for the 188 network. These two numbers in the parentheses are your distance values. The one on the right, that's the reported distance, the advertised distance. So this is what your neighbor thinks that his distance is to reach that network. This is my own feasible distance, or what you might think of as my total distance to get to that route from this neighbor. Okay? So very important. And notice that the best distance I have, the feasible distance, goes up here, right? Normally these two numbers match. Let's do an example of one other one. I'm going to go here to, right now I'm back to referencing this diagram. I'm looking at this one between 18, 19, and 20. And I'm going to go onto R20 and configure a loopback with the exact same subnet that R18 has. So let's go to R20. Interface loopback 0. First of all, do show interface loop 0. And the reason I'm doing this is because I want to see what delay value it comes up with for a loopback. And the delay is 5,000 microseconds. So I'm going to say delay in tens of microseconds. Okay. So if I typed in a delay of 500, that should keep it the same. That should not change anything. Let's just see. Yep. Okay, because it's in tens of microseconds. So now I'm going to change it to something much worse. How about a delay of 100? Actually make it worse. Instead of 5,000, let's do 500. Let's do 2,000. Now let's do 2,500. Which is actually 25,000 microseconds. So I've just made EIGRP believe that this link is slower than it really is. And so now I'm going to add that same subnet in there. Okay, let's see if this guy's set up to advertise that or if I have to do something extra in EIGRP. Nope, he should already advertise it. Okay, so now let's go back to R19. Take a look at his topology table. Does he still have that neighbor? He does. Oh, do we still have the same issue of duplicate router IDs? I may not have, see, 19, yeah, this should not be 19. Okay. Router EIGRP 1819, do show run. All right. Show IP EIGRP neighbor. Okay, that looks good. And okay. You might be wondering, why did he type in the all-links keyword? We'll talk about that. I'll get to that later. But this is what I wanted to show you. So now we can see here that the router in the middle, router 19, has received the 188.188.188 network from two neighbors. We see it here. And we can see the reported distance is definitely different. So the one on the top is much closer, a much lower reported distance. And when we do our final calculations, router 19 says, well, my feasible distance via router 18, which is the .18 router, is 156,000, and my feasible distance via router 20 is 668,000. So clearly the route via router 18 is the best one. So he takes that feasible distance, copies it here, and then you can actually see this in the routing table itself. That's the metric that shows up in the routing table. There it is. There's our administrative distance, and there is our feasible distance. So that's all we really need to talk about in this section about feasible distance and reported distance. So here we've covered what the concepts are, what the difference is between the two of them, and how the router comes up with these, and where you actually see it in the topology table. So we've covered that. So in the next section, we're going to start getting into actually manipulating these metrics. If I want to force EIGRP to use one path or another, what are some ways that I can manipulate or artificially change these distance values to get the result that I want?